So let's make a review about last session. Last session, we tried to see how it's going inside a frame of 82.11. We described how this everything looks like exactly, and each of this address 1, address 2 sequence, and each of them, what does they mean? We were talking till here, and today, this is today we will talk, because last session we haven't talked about this.
We cannot see your screen. Hello.
Hello?
We cannot see your screen.
Let's start this session. Now we have another kind of frame, again, between a wireless station and wireless access point, or between two stations if we have ad hoc mode. Do you remember what was ad hoc mode?
Peer-to-peer.
Yeah, exactly. When just one station try to make wireless connection with another wireless station. So it was ad hoc mode. So we had ad hoc mode and infrastructure mode. And in infrastructure mode, we had one access point, and different client could connect to this access point, which mostly we are using infrastructure mode. Anyway, we can have ACK frame. What is an ACK frame? ACK frame is when a sender or receiver, they are sending a message over the wireless network. Another side, they have to send ACK that I've got it, okay, everything is okay. It means that there is nothing changed inside the packet, and packet clearly and without any manipulation, the packet received and delivered to the destination. If you remember last time, we said that there is something called a frame check sequence, as here also we do have it. So this part in ACK is very important, because ACK exactly check this frame check sequence in the previous packet, and of course when he wants to send a new packet to send that I've got it, he will add again a frame check sequence which belongs to this packet, not a previous packet, this packet. To see everything's better, I created some file here. Just a moment, I will show you. I have some prepared file. ACK. This one. Can you see my Wireshark?
Yes.
Yes.
Okay, good. So this is an acknowledgement. I try to capture these packets just separately, each of them. Today we will try to discuss about all of them if we have time. Actually, last time you've seen that to change the mode of your wireless network, you can change it to monitoring mode, and inside the Wireshark, you can check all of these packets. And of course, you can make filter and just export what you wanted. Like here, for example, I just exported one frame. You can export like a couple of frames and make a new Wireshark file and save it for later usage if you need it. So anyway, let's see, from here is much more. This is a frame. I need to make it bigger. And somewhere here, this is. Just a moment, let me find it. Yeah. The type of this packet is acknowledgement packet. Yeah. And inside this packet, no, there is different different encapsulation. Of course, here we are using encapsulation 82.11. And for how long this packet was sent, which number of the frame, and how many bit it was. And this is exactly the packet structure which here we had. So if you wanted to take a look inside the packet, inside the frame actually, here in this way we could check what is this. And how I should be sure that this is acknowledgement packet here from the type and subtype. If you remember, let's come back again here. We had subtype and type here inside the frame control. Yeah. So we are going to check these two sides right now. And acknowledgement here we got it. So let's come back. After acknowledgement, we have power saving. So for wireless adapter, like your phone, for example, your phone is kind of wireless adapter. Or even maybe on your computer, especially laptops, because they're using battery. Sometimes they can go to the power saving mode, which means in power saving mode, wireless shall not be work totally. So just wireless has some electricity inside and is waiting for some kind of packet, which we will see that which kind of packet is that, to start working again, to wake up, you know. So power saving is a mode which your device doesn't work properly, like exactly a sleeping mode. Okay. As here we can see, where's my mouse? Yeah, yeah. As here we can see, there is different kind of packet between a station and access point, which we call them TIM, like traffic information messages, which that access point try to send for a user. Because the station is kind of sleeping mode, and to wake him up, we need to send some packet to wake him up. And of course, as soon as he got this frame, he will send an acknowledgement that, okay, I'm awakened, for example. Yeah. Or if they try to send any kind of data, so again, the acknowledgement shall be sent. If a station finds some AID inside this traffic information message, the power saving frame requests buffer frame from the access point, because he was silent, he was in a sleep mode. So if something came for this station, the station haven't received nothing during the sleep time. Okay. So after he wake up, he said, okay, what's wrong? Give me some information. The buffer, which almost saved in access point, should be requested from the station. So a station make a request. I'm awakened right now. Give me your buffer. Anything's about me. So all the packet which is belongs to this station through the access point will send, and of course for each single of them, station will send an acknowledgement, an ACK, to access point. Let me show you here. Moment. Power saving mode I don't have here. Okay. If what later I will find power saving mode and I will show you it. Another packet is RTS and CTS. RTS and CTS. Open it. RTS and CTS is kind of supplement for CSMA CA. Somebody knows what is CSMA CA? Carrier send multiple access collision avoidance.
Not yet.
Look in layer 2 especially, we may have collision. Collision is when two things moving. These two things can be two frame, two kind of data, and they bump each other, like two car moving and they bump each other. We call it, in real world, we call it kind of accident maybe, but in technical world, we call it collision. So when two packets meet each other exactly face to face, it's called collision. We need some system to avoid this collision. One of the system is carrier sense multiple access collision avoidance. We had also carrier sense multiple access collision detection, CSMA-CD. So other technologies could use, for example, CSMA-CD. Here we have CSMA-CA, collision avoidance. What it works? Instead of this is the wire, for example, which I have. Imagine we are not in wireless. Imagine we are in a wired network. Okay, the first station try to send a packet here, and imagine inside this wire we have just one channel, and we have no other possibility. So when one car, like one-way road, yeah, when one car is moving here, another car cannot move from another side. Yeah, so if I start to send a packet or a frame or any kind of data here, and if another station exactly at the same time send another packet here, so they meet each other, and none of these two packets cannot be delivered normally, because when they meet each other, of course there is some there is a new mixture here. They are not the same packet as they've been. So the frame check sequence for both of them will change. You know, the main things which I sent now is crashed a bit. It's not the same as it was before. Yeah. So that's why none of them cannot be delivered. So we need a methodology to avoid this. So when I send the packet here, another one, firstly, shall listen to the channel. If the channel is free, he is trying to send data over this channel. But if the channel is used for a random time, he will wait and again retry. That channel is free. If again is used, again random time will wait. Till this part is exactly carrier sense because it's listening to the media, carrier. Now here the carrier is one channel, for example, wire, but while we are talking about the wireless, we have like a wireless area, so carrier, any kind of carrier. Maybe we are talking about fiber. Of course, in fiber optic, we don't have such kind of issues and problem, but anyway, the carrier. What is the carrier? Now we are talking about the waves in wireless mode. So carrier sends multiple access. Why multiple access? Because if I'm sending something, another one cannot send something. But when I'm not sending something, he also or she also can send another packet at the same carrier which I had. And this story make a collision avoidance, because none of them, they are not sending something at the same time. There can be one exception. Could one of you describe me one exception here?
No.
The exception can happen when both of them, it's very rare, but still is possible, yeah? Both of them sense the carrier, and both of them, they think that the carrier is free. And again, at the same time, both of them try to send the packet. Okay, in this way we have collision. So we cannot say that we have a totally collision-free network. Yeah, anyway, there is collision. This is one exception here. Yeah. The timer, if you remember right now, I've told you the timer is random. We don't have like a fixed time, like for example, 2 milliseconds. Why? Because if both of them see the carrier is free and they send and the collision happened, now each of them for a random time will wait. One wait, for example, for 3 milliseconds, another one for 5 milliseconds. So the lower time start to send, and now the carrier is busy, so another one cannot send a packet. So we won't repeat this collision more and more, okay? So in this way, we have collision, but we avoid the collision to happen again more and more. So just in case. RTS CTS exactly the supplement for CSMA CA mechanism. Like ready to send, like RTS is a stand for ready to send. Here, starting with a beacon, and after this beacon, we have this one, request to send flag. Let's check here again inside the frame. This is request to send. The rest of the packet is as usual. Everything like usual. The most important part for us is this part. Who is the sender? Who is the receiver? Who is the sender? Now here from the like between two nodes, we had two nodes here. After RTS, we have CTS, clear to send. So node 2 say that, okay, everything is clear. You can send me anything you want to avoid collision. And then the data will go, any kind of data. We don't care what is inside, it's any kind of data. And of course, acknowledgement, the ACK packet, the first packet which today we were talking about. This is acknowledgement. In the method which I described you, carrier sense, in the beginning, the stations was trying to carrier the sense exactly the carrier. But here, as you see, we have another packet, CTS, clear to send from another station in this network. You know, this Cisco devices wanted to send something, and now the Cisco devices is a receiver. Inside this, you can also see is receiver, and here you can see that he wanted to send this address to this MAC address, because we are in layer 2, everything is with MAC address. We are not talking about IP right now because IP belongs to layer 3. So now we are in layer 2. All the addresses are layer 2. We are talking about the frames exactly. So as look at this Cisco MAC address 00 and 7C. Here we have the receiver. Who sent this? This one. Because in wireless network, we are not always in ad hoc mode. We may be in infrastructure mode, which is more popular even. And at the same time, it's possible different station try to send something to this client. So he have to say that I have free channel for you. In the channel you want to talk to me, I have free channel for you to talk at the same channel. So if another one at the same channel, at the same everything, wants to send packet, he won't send this clear to send. And of course, the second who was started all of this negotiation won't send the data because haven't received clear to send. Everything is clear?
Something like.
Look, even right now we had the same methodology, kind of, because I wanted to send another data. First, I asked that everything is clear for you, and if you all say that yes, everything is clear, so I'm trying to give another data to you. Yeah, and if you got everything, you will send me an acknowledgement. Yeah, I got it, everything is okay. This is how in wireless works. So right now, if I want to do everything like CSMA CA with this RTS CTS, I have to say, Valentin, everything okay with you? Pablo, everything okay with you? Bill, everything okay with you? So for each of you, I have to send a separated RTS packet with my source. Where is RTS packet? Here. With my source and each of your destination, each of you as destination. And if I got that yes, everything is okay from each of you, so I can send my data to each of you again. So right now I'm broadcasting my messages because I'm telling something to all of you. Of course, that's not for broadcasting, but imagine that separately to each of you I'm talking, so I'm unicasting to each of you. So in this case, that I have to unicast to each of you my RTS, you will unicast me back your CTS, and then I will unicast to each of you my data, and I'm waiting for your acknowledgement for each part of the data which I'm sending you. Now everything is clear?
Yes.
Okay.
Yeah. Clear.
Great. So, moment. I wanted to say something more here. Just a moment. There is just a moment. This part. These two you can find here. This is subtype number 11, request to send, and clear to send CTS is subtype number 12, and then we are sending the data, which is of course subtype 0. And acknowledgement subtype number 13. I think in this part, RTS, CTS, and acknowledgement. And as you see here is binary. So 8 plus 2 plus 1, 11, 8 plus 4, 12, 8 plus 4 plus 1, 13. This 3 frame which we were talking about. Can you see?
Yes.
Okay.
But can you make it wider,
Bigger. Okay.
like
Okay.
full screen?
Again, I will send all of this material to this Google Classroom. Oh, this. Sure, 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 sure. After the class, I will join you to Google also. Smaller. ACK, we were talking. Power saving, we were talking. Ups the RTS, CTS, we were talking. This is more detail about this RTS, CTS, which I described you exactly there. So this subtype in last session slide, we had it. Now also here, we have it again. So everything okay. And we are in beacon frame. If there is no question, okay, Paul, I will join you also. Everybody after the class, I will join everybody again to this Google Classroom. Okay. Hello, hello.
Sure.
Everybody can hear me?
Yes.
Okay.
Yes.
Yes, I hear you.
Great, great, great. So about the beacons, let's take a look on one beacon packet and then where is my notes? And describe it. That's a beacon packet. Beacon frame. Sorry. Beacon frame, exactly they are the most famous and most popular and most common packet as maybe approximately 10 or even more times in a second. You can find them in each wireless network because they are playing really big role there. And we need them also in the future. Beacons are broadcasted, so just to show you here. The first was beacon and it was broadcast. And you know that a broadcast address in layer 2 as a MAC is all bits shall be 1. So it's FF, like 6 pair of F beside each other. This is broadcast address in for MAC address. So beacons are broadcasted. Come back here. The structure. What is the usage of each beacon? The beacon make the network synchronized. So to be sure that everything is synchronized, a wireless network needs this beacon packet. Inside the beacon packet, you can see many useful information. That's why exactly we will take advantage of this beacon a bit later. For example, the SSID, the name of the wireless network, is exactly in this beacon. The data rate, for example, different part of this I'm trying to describe you exactly. The SSID, for example, yeah. So the data rate also is inside this. So with which speed you can talk to another devices. Here exactly you can find. There are a lot of information here, as you can see. So in some cases, even the country information, like many power constant, many of them they are very interesting. But later, especially this SSID will help us a lot because, as we know, we can hide the wireless name. So one of the security level for wireless is to hide the SSID. So in this case, if somebody wants to join to your wireless, in addition to password, they have to write exactly manually write the wireless name as SSID. They have to write it, and it's case sensitive, of course. Maybe sometimes you search some network and you've seen unknown name or unknown network among your list. So this unknown network or unknown name, it means that there is a wireless network, but the SSID is hidden. And how later on we want to take advantage of beacon, we can see inside the beacon the link of this SSID, and with some tools it's possible to even find it out somehow. So that's why later this beacon can be useful for us. It's one of the interesting frames in layer 2 in wireless network, which we will try to take advantage of. Let me open a beacon for you. Where I have this beacon. Beacon here. Okay, here there is 2 beacon packet. Beacon frame. That's a beacon frame. As we can see, the interval here is 61, almost. Let me open it for you. Yep. Just a second. Here. We close some of them because there is not enough space here, and later I will open them again. Here. The interval here is about 61.44 seconds. The byte shows about 60. The difference is because this is like it should be multiply of 1024. So these things which you see here is added is because always it have to be multiplied by 1024 millisecond. So it's about 1 second, 0.024 seconds, something like that. We can see that the access point was send this packet, this frame. Transmitter is access point, the beacon. Also, we can see transmitter belongs to a BSS. Last session we were talking about the BSS. Another one, the privacy can allow WEP. Other things which can be interesting here. Automatic power saving delivery is not implemented, so we are in power saving mode. And that's it. Inside this one, we have not too much with information to be useful right now at least. Okay. So each frame has some prop frame. If we have some access point, not a peer-to-peer network, if we are not in ad hoc mode, if we are in infrastructure mode, so each frame has a prop frame. So for each prop frame, we have a frame, a prop request and a prop response for them. So let me come back here. Prop. Prop request and response here. I'll just firstly take a look of in frame talking about this. This is prop frame and this is a prop request here. Yeah. So, because I wanted to share this with you, so I tried to, as much as possible, put the screenshots here. So you have everything which I wanted to tell you inside this PowerPoint and the screenshot which you may need them. So don't be worried. I will try to share also these files with you if you want to research inside them and learn more and see the details yourself, so you can have them. But anyway, I have to describe where are we? Prop frame. When a station try to send some things to access point, we need a prop frame here. So inside the prop frame, again, as usual, we have header, we have frame body, and inside the frame body, again, we have this SSID as you see. So from different place, we can check this SSID. Sorry, we have this SSID, and we can compare them. And in case that they try to hide this SSID, we can find it out exactly. So, for example, here in these two slides, the difference between two prop requests, as you see here, the name is a part, and I've seen the SSID parameter here, but this one, he tried to hide it. It's hidden, but I know that this is 7 byte for that. So it exactly helped me to understand that what is the length of this SSID. So if we come back here, this war chart, again, if you try to open this prop request, this is the SSID parameter here is set as a part. The tag length is 6. And here No, here also we have. Here also we have. No, it seems that here among this packet I don't have. I forget to put for you this hidden SSID. But if here this part was hidden, and if we didn't have this one in screenshots, you had it just in this pickup file. I forget to put it for you. You had here like with nothing, with no data. Here everything was like nothing, 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 0, 0, 0. But here the tag length, still you could see that this is 6. 1, 2, 3, 4, 5, 6. So this is a prob request. And let's continue with prob response. This is prob response. Just a moment. Just a second, please. Something here I cannot see. But something. Here. At the same SSID, like the network which we are, if the prob request sent exactly on this SSID, we have to respond it exactly on the same SSID. Okay, so from the source and destination, from both sides, this SSID have to be the same. So in two packet, if you got it from like two different stations, and if you see that these two different stations, they have the difference, so you can understand that they are not belongs to the same network. Just a moment, let me find this wireless adapter to show you something in real mode. One moment. So I have this wireless LAN right now. So wireless LAN 0. Now I have this wireless LAN 0 moon in monitor mode. Also at the same time, let me without saving. I need them. Sniffing to Warshard. Wireless LAN in monitor mode. Let's start it here. Need them later. Oh, sorry. So let's wait a few seconds here to show you something. Okay. You see here BSS ID, which is the MAC address of access point. For example, this access point. Yep. 90 F6 and ending with 44. For all of them, I have different devices here. So at least 4 devices here I can see which is connected to this network. And this is the SSID of this network. How this air dump helped me to exactly understand who is connected to which access point. Exactly with the help of this probe package, for example, probe frames, for example, and the beacons, of course, trying to check, okay, this is the beacon which was broadcasted, and this is a probe which was sent exactly, and we had probe response from this kind of stations to exactly this access point. So we understand that this is belongs to this one. While exactly I can see inside this access point, I have this SSID, and exactly he or she is sending the same frame with the same SSID. Because sometimes it's possible that one access point broadcasting different SSID. Some access point they have these capabilities to send different SSIDs. So even you can understand each client connected and joined to which SSID exactly here. And if there is different, you can see here even the name of that. So everything is clear?
Yep. Yes.
Okay. Now, step by step, we are trying to see, while we are going to study all of these theories about inside these packets, because if we know how they work, we can use this kind of tools much more better. Because as you see, you have to know about all of these packet details, and at the same time, when you are coming here, let me stop it. Maybe before, here for you it was many question marks, but right now, what is the beacon frame? You know what is request to send. After request to send here, because I stopped, we haven't seen this clear to send. You know that after request to send, you have to look for clear to send maybe. And if you couldn't find the request to send, it means that there is something's wrong or some line is busy. That's why I didn't get request to send after that. You see, the access point tried to talk to some devices and exactly got this possibility. Have clear to send. Now you know what is this acknowledgement. I don't know who is this Beijing X. Maybe some of my neighbors has such a devices. Or what else? Quality of service still we haven't talked. Probe request. Now you know exactly this probe requests and probe responses came from where? And you see exactly inside the SSID. Actually, here you can see these tags better because this is exactly the details of these tags, but here also you can have some information. You can make it bigger. You can see this SSIDs. And of course, you can make apply as filter selected. This is all packet, all frames of this SSI. You see, all of them. We grab. I've sent you in the Google class. Let me open it. Moment, let me open it. Classroom, google.com. This is your course. This two book, this one and this one. If you're interested to be professional users about Wireshark, because this is really, really interesting. Because inside the Wireshark, as you can exactly use all of these filters and searches, so better you can use these tools and you can have much more information, because all of these things, all of these tools which you see, they just wrote something based on such kind of packets. If you see, for example, here the SSIDs, exactly it came from here. If you see the SSIDs, they exactly came from this part. They trying to capture all of this, for example, layer 2 frame, and exactly filter this part, and they show you, this MAC address which belongs to this access point has this SSID, for example. So you can see D754 in the end has this kind of SSID here. And all of this information exactly came from this frames, packets, or different layers, different names, you don't care, yeah? So exactly how much you know Wireshark or TCP dump, because TCP dump is a text-based tools works like Wireshark. You can even write your own code instead of using, I don't know, this AeroDump or something like that. You can write your own code, yeah? Or at least if you want to use some of these codes, you can modify them in the way which you want. So if you need something which they don't have, so you can add a feature, because all of this AeroDump or some of this, let me again come back, like AeroDump, you can find, for example, Python scripts for them, just randomly. I don't know what is that, just randomly. Somebody tries, for example, here to write something maybe to crack, I think, some password. Later on in authentication, we will see these authentication packets. So as you see, they are using hashcat. Hashcat is because the password, it's encrypted and coded. So to try to unencrypt it, actually to not decrypt it, but to brute force it. So they were using, for example, a hashcat maybe inside their codes or something. So as you see, later on, you can write your own code based on what here you got. And exactly these things is based on such kind of tools. So try to learn this Wireshark, because for diagnostics, not just in wireless, but in any kind of network. If you want to be a network administrator, with the help of Wireshark, you are like a hero, because you exactly can see every single packet and you can see what's going on inside your network, and exactly professionally, you can see the details and you can diagnose your network easily. So if you want to be, I don't know, security analysis, so again, you have to come inside your packet exactly inside your packet and see what's going on, like a doctor, when a doctor wants to see what's going on with your body, they are sending you to, I don't know, blood analysis, or I don't know, some x-ray or something. They want to see what's going on inside your body. So if you want to protect your network exactly, first you need to understand what you have to protect, and to exactly which point put this protection, and how each of this protection works exactly, again, you need inside of this packet. Vice versa, if you want to perform some kind of attack to any kind of network, again, you need to understand inside of the packet, because we are not going to make something new. We are exactly reusing or abusing or taking advantage of what is exactly available, and we try to just, with the help of them, do something. Especially after authentication, you can see about what am I talking. So, if everything's okay, let's continue.
Yes, almost okay.
Okay. So, where we've been? We've been, yeah. I will try to add this one and then upload this packet for you to have this SSID, like hidden SSID, let's say. Anyway. This was, we were talking, we've seen, authentication. So, how much time do we have? You're not tired?
Not yet.
Okay, good. So I will try to talk about this authentication. Then let me find the authentication packet here. Authentication, where is it?
This is the most interesting part.
It can be one of the interesting parts, and unfortunately you have some assignment for this part. So because to authentication I will talk, and the third one is your assignment, but interesting. And file name, authentication. This is authentication. Oops. So let's start. Inside authentication frame, we have some algorithm. So here, this is again beacon, and here we have authentication. Let's see the authentication from inside. Fixed parameter, and here we have algorithm. Here there is open system. If we have here instead of 0, 1, because there is just a bit here, so it can be 0 or 1. So if here it mentioned 1, it means that we have a shared key authentication. If here we have 0, so it means that we have open system authentication. So let's come here. Not inside. In another one, we have this shared key. So okay, next authentication I will show you. First, let's describe this structure. The authentication process totally consists of several authentication frame, and we cannot say that there is 5 or 4 or 3 because depends on two end of the authentication. Now, let's say if we are talking about infrastructure mode, the access point and the station. In addition to the method of authentication which they are using, if they are using WEP or WPA or WPA2, or if there is WPA2 PSK, pre-shared key, or if there is WPA2, I don't know, enterprise, which they have to connect to the radio server and again re-authenticate back. So each of this process, because we don't know what we want to talk, so authentication frame, they can be 5, 4, more or less even. No, we exactly don't know how many frame we have to look for one authentication, one station authentication. There is something called authentication sequence. This one, as you see here, it was 1. Here is 2. Changing. The authentication sequence, there is a number to track of current state of authentication process, because I've said that we don't know how many frame and packet we have to send and receive during this authentication. So to keep tracking in which state are we in this during this authentication, so we need something called sequence here. So if you got some unordered frames from different networks, and if you sort them based on this authentication sequence, so you can see, this was the first step, second step, third step. In this way, authentication was going on. This number totally can be from 1 to 65,535. This is a very famous number, of course. So, you can remember that. And after that, so 65,535, again, we will return back to the first one. So again, 1, 2, 3. So it cannot happen, but if the authentication process goes more than 65, something, so the next frame is again 1, number 1. Here we have something called again a status code. Here it was successful. So if we had successful authentication, so congratulations. If any other number than 0 we found here, it means that we have some failure. So this part can be 0 or it can be any other number. Any other number means that there is error here. So after authentication, we have association. Where is association? Oh, yeah. Yeah. Again, here there is beacon. Here is association. Association structure. Parameter, tagged parameter. Tagged parameter again here is the SSID. Let me just show you the structure of this. Association, that's the structure of that. So as you see, you can see the SSID here, for example. You have to see, you can see a supported rate, for example, which is very interesting here. As we can see, the access point which here I was communicating with has maximum 11 megabit per second. So it started from 1 So it can be the next frame rate can be 2 megabit, then 5.5 megabit. This is what the access point was supporting. Here we have another one. No, this is also, it has maximum 11. So if, for example, you found here something like more than 54, for example, you could find here 150. So you could be sure that the access point support N, 82.11n. So if we have here something like for example, 54 megabit per second, you could be sure that your access point can support this, what it called, G, 82.11 G, for example. So without knowing the standards here, even by the supported rates, you can find out the exact standard. So there is different places which you can obtain information, and based on those information, you could complete your puzzle exactly. What I wanted to say, SSID, we said. Oh, that's it. This is the request, and this is the response of that packet. In response also, there's not something special. Again, the same things which we could see here. That's it. That's it. That's it. That's it. But after association, we have the authentication packet. Oh, yeah. Where is it? Oh, the authentication. Oh, that's one of my favorite. Again, let's come back here. See the authentication packet. If you have any question, ask any question. I will drink water. I will continue. Any question?
No, thank you.
I don't have questions.
I don't have questions.
Okay.
But all presentation you may.
I shared with you. Yeah.
Okay.
Yeah. Where is it? That was the first session presentation. The second, I forget to share, actually. I will share it again. And that was the video of previous session. And okay, and this session also I will add this presentation.
No, there is.
There is? Oh, here. Yeah, yeah. Oh, yeah, session 2. It's course material. Yeah, the course material here. Session 2 is available. So you can download it, yes. And today, after the class, maybe till night, I will upload this session 3 also. You can use it. Because there is many details, as much as possible, with pictures and screenshots and everything. And these files also I will share with you. This few files I will share with you. Can be useful. Okay. Let's take a look of reason code. here you can see inside the body there is something called reason code, which is about 2 bytes. And this reason code could be one of these many different options which we have here. For example, access point is busy. Access point don't want to respond. Yeah. Or for example, the association. No, the station just try to disconnect from the network. When you click and push disconnect from one network, or when you run or move from one network to another network, so sorry, so you have to disconnect and deassociate from this access point first, and then go to another access point. No? So with one network adapter at the same time, you cannot be connected in 2 different networks. So when you want to disconnect from the first and leave the network, so you have some reason code here, which is inside this body of this the association, or we can call it as the authentication. So let's come back to our file and let's check, for example, where's my mouse? Let's check here. Here. Here we had authentication. After authentication, we had the authentication. So there is a reason code here. Previous authentication no longer valid. So imagine that while you are connected to wireless network, they make some changes for authentication. So your previous authentication cannot work right now. The password changed, I don't know, or something like that. Yeah, or the authentication method they changed. No, mostly the access point asks for a reboot for all of this. So logically, all stations are disconnected ones, and they have to reconnect. But imagine that you have kind of access point that without reboot try to change this, for example, authentication. So in this case, you may have such kind of the authentication error, for example. It can happen. Now, especially if you're using, for example, radius. What is the radius? It's like when you have a client and there is access point, and this access point not authenticating these stations by itself. He sent the request to another server, a third server here, and a third server has like authentication system, like AAA, authentication, authorization, and accounting system here. For example, some users just since morning till 2 p.m. can be connected. Another user just 2 hours a day can be connected. I don't know, some accounting system here they may have. So when a station sending the information to this access point, the access point shall check it with like another server to be sure. We call it radius server. This radius server to be sure that he can be authenticated, and then if everything is okay, this client can be authenticated. Mostly in such cases, if something's changed here, so you can have such kind of messages. This is one of the case I just described. And another case I say that if your access point without reboot can change the authentication, like password or something. So again, you may have such kind of what it called reason code here. So why this packet is interesting for me? Let me ask you, with this information which you have right now, how you can abuse this kind of information just today which you obtain, all of this information which you obtain, how you can abuse it, especially this the authentication, how it can be useful for you.
Uh, by how can you abuse it? I don't understand.
So now you know, for example, how this kind of frame works, yeah? So how this information can be useful for you. You can be attacker. For example, imagine that you're an attacker.
Can
This
we
is
use
what
any level using this package to be interrupted? And can it be some sort of man-in-the-middle attack using such?
No, no. Another?
I don't know. Maybe you can know SSID.
No case society we were talking. Now let's talk about this authentication and the authentication.
Okay.
Yeah.
Yeah. Maybe it could authenticate. Maybe you can send a new package with your data, whatever data you would like to have, and then you can authenticate yourself to access some sort of specific.
Later we will try it, but with what we learned today, no, actually we cannot do this. We need much more, a bit more information to make such kind of attacking. But no, another one. Try to tell anything which is in your mind. Come on. You have to be creative, as attacker always. You have to be very creative and exactly find an interesting way to teasing whom is in front of you. And as defender, as who wants to protect the network, exactly, you should know everything which attacker knows plus how to defend it, because destroying is so easy, but constructing and making everything is so hard. So you have to know everything which attacker knows in very good and creative way, and plus, you have to know how to defend all of these things. So now try to be an attacker without knowing how to be protect everything. Just try to be a creative attacker. Imagine that we are sitting in, I don't know, an airport, and now just you want to teasing people. That's it.
Maybe change the. Maybe just trying to disconnect all of them.
Yes. How?
Like when you receive the package, you authenticate. For example, you remember you had a project at the university where you changed the Wi-Fi to your name and then just disconnect everybody else if you duplicated the network name.
No, duplicating the network name and a society, it's plus we need something more. We need the power. We have to perform a higher power than another access point, then another clients, instead of joining the real access point, they automatically rejoin to us, because we have such a rule in wireless network. The higher power is higher priority. So if, for example, we have two access points with the same SSID, this called is roaming. Like, for example, even while your mobile phone, you drive over the city, automatically from one access point, which is one of the mobile BTS, you roam to another mobile BTS. Yeah. So to have the full coverage, they put this functionality inside the wireless framework and wireless protocol, all wireless protocols. So yes, this can work, but not for this scenario. Yeah, and that one not make everybody disconnected from the network. It's just make from one access point to another access point, and later we will perform such kind of attack exactly in the real world. With this colleague, we will try this kind of attack, and this is one of the way which we can, for example, perform another attack in behalf of that. For example, this man in the middle, which you mentioned, it can be after this kind of attack. So firstly, you roam all of them to your device, and from your device, you try to perform another attack like man in the middle. But no, if you want to disconnect other clients, no, that's not a way which you can do it, because you cannot have such kind of power. So you need, very huge antenna or very powerful antenna you may need to, for example, if you are sitting in airport is very big. So not with 1 or 5 dB antenna, which is like the size of your hands, you can make such kind of attack. It's just for the people who is near you by, very near you by. In addition, that for such kind of attack, you have to know exactly the authentication, everything. Because if somebody is connected to a network and if they want to roam to another network and access point, so they have to, these two access points should be exactly the same configuration. Like if using WEP, so here should be WEP. If here is, for example, WPA2, here should be WPA2. If the password is, for example, hello12345, here should be hello12345. So everything shall be exactly the same. Otherwise, we have no roaming. So for airport scenario, as here we try to just teasing people for nothing, just because we are not good people, maybe. So that doesn't work.
What if just gathering data from the people nearby at the airport, or just sending them a specific
No,
kind?
this is totally another. This is gathering the data or something. This is man in the middle, which is totally a different kind of attack. It's not about the
I'm
authentication.
talking about like the authentication itself. When you authenticate yourself as the owner of a specific data, maybe I would, like, if I got.
And what if I'm not authenticating that network? Imagine that I have no password. I ask somebody to give me the password. Imagine you are going to a party or restaurant or I don't know, somewhere. You ask for authentication key and they say, oh, sorry, we cannot give you the key to be authenticated in your wireless network. And just you're angry and you want to disconnect everybody else if you are not using the wireless, so nobody don't use it.
Mhm. Yeah.
Come on, everybody else. So okay, I'm telling. Let's come back here. What if, let's say, example that this example, just example, or or this one first. What if you broadcast or unicast to each of the client? Actually, you've seen how you can see each client's MAC address. Here you could see all stations which is near you by. Okay, so you have their MAC address. There is no worries to find their MAC address. Very easy, you can find them. So just easily you can send the frame to them and put a reason inside like this. That's it. Or like this. The access point is busy. That's it. Because this is inside the wireless protocol, so when a station sees such kind of packet, such kind of frames, they say, oops, now I am like disconnected from the network. And if you keep sending such kind of packet, he cannot retry for authentication, because he try for authentication, automatically he disconnect and like de-authenticate. Again, he try automatically to authenticate, again disconnect. So, and if for each single station or broadcasting, if there is possibility, if there is no possibility, to just automatically write a code to just one by one take all of this and send the authentication packet, and each inside of each frames, where is it? As a reason, we say that we can make something like that, yeah, because here even we can see this. So we can regenerate such kind of packet. And as a reason, imagine instead of that, I could put, for example, here 1. What was 1? Like client associated, but no longer authorized. So there is no authorization access for the client. So client looking for another network. Or for example, imagine you put 5 inside, and then the access point is busy right now. Or you can play. This list is so big, and you can find it like in Wikipedia or somewhere, or the internet. You can find this list fully.
Just a simple approach, like write it down as the same.
Yeah, exactly. You can write the authentication packet to the this is the receiver. This is to this destination, and this destination is exactly who you want to disconnect exactly. And if you send them something like this, exactly the same packet, if you just repeat this packet, repeat this frame, exactly the same packet, repeat it, and just put another reason code inside. So definitely the client, because this is a protocol, this is how wireless works exactly. Okay, so the client start to be disconnected. Just a second. Let me show you something, if possible. Where is it? Here. You see? The same tool, because this air something which we are using is like airmon ng, air dump ng, air reply ng. This is like a package. They are all together. So with airmon ng, you change your wireless mode to monitor mode. With air dump, you can just see and scan everything, and with air reply, you can make some packet and frame as you want. So if I start to use deauthentication reply, and then I can use some code the reason code which I wanted. Say the default is 7. So the default is no association station. So the default say that nobody is not here. Let's say in this. So the door which you knock, nobody is not home. So, but you can change it to any of them you like. So if I say that you could change it to 5, so here easily you could change it to number 5. Yeah, and also here it's possible to there is, let me find the dash C. Here, the destination MAC. You could disconnect just one client, or you could like disconnect everybody. So here, imagine that I was using like this, and for example, like imagine.
A quick question, please. Like, when you, like in most of the cases, if you have just like the password of the network, you would be able to disconnect everybody, or also is it possible to do that even if you don't get access to the network?
I don't have access. I say that imagine that you are going to party and you ask your friends to give you a wireless password, and just they don't want to give you the wireless password, and you can say, okay, because I'm not using wireless, so I'm not letting you use wireless as well. So that's
Wow.
it.
Yeah. Okay. Is it the same protocols you write like the same thing even when you get access, or it's
Yeah,
different?
the same way. Of course, if you get access, you have more possibilities because you have more access, of course. So you have more possibilities. You can even maybe connect it to the access point and make them blacklist, or many more possibilities you may have. So, but for now, for the authentication, we don't need to have access to the network. You see, the only things which I need here is just to have this MAC address of client, and also I need the access point which he connected. And for access point here is BSS ID, which access point is connected. So if I've tried imagine this one as a client, so this is destination address and this is BSS ID. I should put, for example, -A, like this. And then I have to say true W, something like this. Actually, this client is not connected to this access point from another place. Which access point is that? Starting with 90. Starting with 90. So one of those, maybe this one. I hope not my laptop, because this is my home wireless network. If I got disconnected, so it's because of something like this. Oops, something wrong. No, the out. What is that? For example, here I can say send the authentication packet. What's wrong again? So in this way, it works. I don't know which devices I'm going to. Oh, no BSS ID. So somewhere I just copied something wrong. So maybe this access point is not available anymore or something. So anyway, the command is like that. you can just send the authentication packet, how many you need them. So I'm just using the default. So the reason is 7. The client which I want to disconnect is this one. And the access point which I want to send the authentication packet is this one. And through which wireless adapter? Through this wireless adapter. Because if you remember, so with change or wireless network, it was WLAN 0, but when we were using this airmon-ng start this wireless LAN 0, now we are in monitoring mode, so that's why we can do all of these things. That's why we can inject inside the packets. So now our wireless LAN network called WLAN 0 mode. So this is the wireless LAN which we have to use. That's it. That fake authentication which you said, it was this one. But we need more information still. We have to learn a bit more and then later we can use fake authentication. Any question? Hello?
No.
Yeah.
So we are here. So if I start this one, I have to go through all of that. So maybe not today, maybe another day. So we are on slide number 50 and I have to add something more for next session. So, okay. Maybe enough, yeah? Because I got tired. I don't know. How about you?
Yeah, a little bit.
Okay. Yeah, look, again, I'm telling, I know that this is too much theory and too much details. I really understand that that can be not tasty for you. But as you see, when you are going to the real world and when you want to exactly perform a real attack, yes, you can find this kind of syntax from the internet and you can just use it without knowing what's going on your network, and just use it. And of course it works, definitely it works, yeah. But in order to understand the situation and if something's changed, if for example some kind of I don't know, for example, imagine the default reason as 7 was blocked from some other place. So you have to know how to change it, and you have to check it by yourself. What's going on when I'm sending such kind of packet? Why I cannot, for example, get the result as I want? And all of these questions later, you have to know all of these very small details inside, especially if you want to write your own like tools, because the tools which are available, they are great. I know that I'm using all of these tools, but they are powerful if you mix them with your own situation and with your own function. So these tools are created to not just be used, they created to be reused in the way which you wanted. So that's why they are open source and you can find them easily, maybe in GitHub or like the source is available easily. So you can find them and you can change them in the way you need, and then welcome, you can use them. So you need to know all of these untasty theories in order to know how to perform an attack, and much more important, how to protect your network against this kind of attack. So even maybe without my description and without any additional word, maybe even now you can guess that how you can be protected against it. For example, the authentication frame, just the simple things which today we were talking. Yeah. So when you know how it's exactly everything's going on, the details, so you by yourself can make your own defense solution, and you can even vice versa, maybe attack solution, attack perform. So that's it. I hope you enjoyed. Please, two guys requested for this Google. I will add you right now after this session, and please, if there is some assignment, try to solve it. Try to check Google. Try to check this what it called Moodle, Google Moodle. Yeah, and take care of yourself.
Thank you so
Thank
much.
you.
Okay, thank you.
Goodbye.
Thank you.
Goodbye. Goodbye.
Bye.
Goodbye.
Take care.